For more than 3 decades, the Hubble Space Telescope has been our eye in the sky, revealing newborn stars and dying galaxies in the deepest regions of space. It captured the deep fields, showing us the dawn of time itself. But now, NASA is preparing another powerful observatory, one designed to map the universe on a scale never attempted before. Introducing the Nancy Grace Roman Space Telescope. The next chapter in our quest to understand the infinite, Roman is scheduled to launch on August 30th, 2026. Its journey will begin at the historic Kennedy Space Center, carried into the heavens by a SpaceX Falcon Heavy. This massive rocket, with its 3 cores strapped together, represents the peak of modern aerospace engineering, ready to deliver our newest lens to the stars. The telescope is named after Dr. Nancy Grace Roman, NASA's first chief astronomer. Often called the mother of Hubble, she fought for the vision of space-based observatories. Her legacy lives on in this mission. Roman features a 2.4-meter primary mirror, the same size as Hubble's, but with a vision that is vastly more expansive. Over its 5-year primary mission, Roman will tackle the biggest mysteries in physics: dark matter, dark energy, and the evolution of cosmic structures. It will also search for exoplanets, worlds orbiting distant stars, helping us understand if we are truly alone in the galaxy. After its launch, Roman will travel approximately 1.5 million kilometers away from Earth, heading toward the Sun-Earth L2 Lagrange point. In this stable region of gravitational balance, Roman will remain shielded from the heat of the Sun and the light of the Earth. There, it will silently collect light that has traveled across the universe for billions of years, capturing photons from the very first galaxies. But its greatest power is not only how deeply it can see, it is how much of the universe it can see at once. Roman's field of view is 100 times larger than Hubble's. It's like moving from a straw to a wide-angle lens, allowing us to survey the sky with unprecedented speed. We are on the verge of a new cosmic revolution. The Nancy Grace Roman Space Telescope will rewrite the story of our universe, one wide-field image at a time. Welcome to a new era of discovery. For decades, the Hubble Space Telescope has been our premier window into the vast, glittering mysteries of the cosmos. But as we stand on the shoulders of giants, a new titan is rising. The Nancy Grace Roman Space Telescope, designed to redefine our perspective. The difference is staggering. While Hubble captures a pinpoint view of the sky, Roman sees a territory 100 times larger in a single gaze. Imagine looking through a needle's eye versus a panoramic window. This massive expansion allows us to map the universe with unprecedented speed and scale. At its heart is the Wide Field instrument. This marvel of engineering features a 300-megapixel camera, delivering incredible clarity across vast distances. Every snapshot is a goldmine of data, revealing individual stars tucked away in distant galaxies that were once just blurry smudges of light. Efficiency is Roman's superpower. It can survey the heavens 1,000 times faster than Hubble, moving with a relentless, sweeping pace. In just a few months, it will collect more data than Hubble did in 30 years, capturing panoramas filled with thousands of ancient galaxies. The universe is far from static. Roman is built to witness its dynamic pulse, watching for the sudden, violent death of massive stars. It will also detect the subtle shadows of distant planets. By watching stars flicker, we can find worlds orbiting stars thousands of light years away. Through repeated observations, we create a cosmic time-lapse. We can finally see the universe in motion, evolving right before our eyes over time. This isn't just photography, it's a study of change. From cosmic collisions to the expansion of space itself, nothing remains hidden from Roman's view. The sheer volume of data is immense. Digital pulses stream back to Earth, where supercomputers work tirelessly to decode the secrets of the dark. Machine learning algorithms scan for the unexpected. They highlight strange anomalies and bright spots that defy our current understanding of the physical world. We are looking into the void. A slow zoom into a dark, empty patch of space reveals that it isn't empty at all. Faint, weirdly shaped celestial objects emerge from the shadows. These are the things scientists haven't even named yet, waiting to be understood. The static photographs of our history are dissolving. In their place, we are building a swirling three-dimensional moving atlas of the entire known cosmos. This searching atlas is more than a map. It is a guide for future explorers, pointing the way toward the most intriguing corners of space. Finally, we dive into the heart of dense star fields. Here, thousands of hidden worlds begin to glow, signaling a new chapter in our quest. The Roman telescope is our bridge to the unknown. Join us as we search for these hidden planets and unlock the secrets of our universe. Somewhere in the Milky Way, a planet may be orbiting a star that no human has ever noticed. It could have oceans, storms, or an atmosphere completely unlike anything in our solar system. Scientists expect the Nancy Grace Roman Space Telescope's observations to reveal around 100,000 exoplanets. To find them, we look for shadows. When a planet crosses in front of its star, a phenomenon called the transit method, it blocks a tiny amount of light. Roman will monitor enormous numbers of stars, searching for these precise repeating changes in brightness. But gravity also acts as a lens. In gravitational microlensing, the gravity of a foreground star can bend and magnify light from a more distant star. If a planet is present, it creates a brief additional signal revealing its existence. Roman will peer toward the crowded center of the Milky Way, discovering vast, diverse worlds, rocky planets, frozen globes, gas giants, and distant orbiters. Its coronagraph instrument will test advanced technology designed to block overwhelming starlight, helping us see faint planets and planet-forming disks clearly. While Roman is not guaranteed to discover alien life, it will teach us how common different types of planets are across the galaxy. One planet is a mystery. 100,000 planets become a map, one that may finally reveal whether our solar system is ordinary or exceptionally rare. But some worlds Roman may find will not orbit any star. They travel alone through eternal darkness. In the vast, silent stretches of our galaxy, there are worlds that know no sun. They are the orphans of the cosmos. Not every planet travels around a star. Some wander through the Milky Way completely alone, without sunlight, seasons, or a sunrise. These are rogue planets, nomadic giants and rocky spheres cast out into the eternal night of interstellar space. To understand where they come from, we must look back at the violent beginnings of planetary systems like our own. In a young solar system, chaos reigns. Gravity is a fickle master, pulling and pushing protoplanets into unstable orbits. When two massive worlds pass too close, the gravitational tug-of-war can be catastrophic for the smaller participant. The loser is violently ejected, flung out of the system at incredible speeds, destined to leave its parent star forever. But ejection isn't the only way a rogue planet is born. Some are born in total isolation, far from any star's warmth. Deep within cosmic nebulae, small clouds of gas and dust can collapse under their own weight, just as stars do. However, these clouds lack the mass to trigger nuclear fusion. Instead of a star, a solitary planet-sized object emerges. Because they don't orbit a star, these worlds are nearly impossible to see. They are dark, cold, and hidden by the void. To find them, astronomers use a technique called gravitational microlensing. It allows us to see the invisible. As a rogue planet passes in front of a distant star, its gravity acts like a magnifying glass, bending and brightening the star's light. This fleeting alignment is our only clue that a wandering world is passing through the neighborhood. Soon, NASA's Roman Space Telescope will scan the heavens, specifically looking for these cosmic ghosts. It is expected to detect hundreds of Earth-mass rogue planets, revealing a population much larger than we ever imagined. The diversity of these worlds is staggering. They are not just frozen rocks, but varied and complex environments. Some are gas giants larger than Jupiter, retaining the internal heat of their formation for billions of years. Others are rocky Earth-sized spheres, locked in a permanent layer of ice that preserves their ancient secrets. Surprisingly, some rogue planets are not truly alone. They carry their own tiny moons into the shadows. Tidal forces between the planet and moon might even provide enough energy to keep a subsurface ocean liquid. Could life exist in these sunless oceans, drifting through the galaxy? It is a question that fuels our curiosity. The discovery of these worlds is changing our understanding of the galaxy. It is more crowded than we ever thought. These worlds may never experience another sunrise, but their existence reveals the violent and beautiful nature of planetary birth. They remind us that the universe is vast, and many of its most profound mysteries are hidden in plain sight. The Milky Way is filled with these silent travelers, each one a story of survival in the cold heart of the galaxy. We will continue to watch the stars, waiting for the brief light that tells us another wanderer has been found. The universe is expanding, but instead of slowing down, that expansion is accelerating. Something invisible appears to be pushing the cosmos apart. Scientists call it dark energy. Dark energy is the name given to this unknown cause, but scientists still do not know what it actually is. The Nancy Grace Roman Space Telescope will study millions of galaxies across enormous distances. It will observe exploding stars called Type Ia supernovae, galaxy clustering, and weak gravitational lensing. Gravitational lensing happens when matter bends the light of distant galaxies. By measuring tiny distortions in galaxy shapes, Roman can help map invisible dark matter. Dark matter and dark energy are different. Dark matter pulls through gravity and helps hold galaxies together, while dark energy is associated with the accelerating expansion of the universe. Roman may not simply map the universe as it exists today. It could reveal how the cosmos changed over time, and whether dark energy is constant, evolving, or evidence that our understanding of gravity is incomplete.
Roman was created to answer specific questions, but history suggests that its greatest discovery may be something no one expected. Every new telescope changes more than astronomy. It changes how humanity understands its place in existence. Roman may show us whether our solar system is common, how galaxies were shaped, and why the universe is expanding faster. On August 30, 2026, a new eye is scheduled to rise above Earth. Its mission will begin with a launch, but its story may continue through discoveries that reshape science for generations. Somewhere inside its first enormous images, the next great cosmic mystery may already be waiting. The Infinite Archive. Subscribe and join us as we uncover the next mystery hidden within the universe.